All right, everybody. So today's lesson is going to be talking about pH, what it stands for, what it means, the different levels from 1 to 14. I'm going to get into some math because pH actually stands for the power of hydrogen. And if you're remembering back to math, powers of 10 is something you spend a lot of time on, and logs and exponents and things of that sort. So pH is a mathematical representation of a certain power, specifically about the concentration of hydrogen. So at this level with the regents, it's not going to be that in depth. I'm going to still give you the information, and I'm going to kind of tell you how to read it in a simple way without necessarily having to take out your graphing calculator, scientific calculator, and figure it out. So let's get into it. So pH. I think most of us, at least before we even got to this unit, understood that pH was a range that went from 1 to 14, or we knew that there were numbers that at least decided if something was an acid or a base. But formally now, it goes from 1 to 14. Some may argue 0, and that's okay. But for the sake of Regents Chem, we'll just say 1 to 14. In the middle of these two numbers is 7. And what we're going to see is that 7 is our neutral point. So this might be a little bit of review for the moment, but that's okay. Just stick with me. So let me get into some stuff here. We're really worried about the concentration of hydrogen, and H plus really. And we kind of use two brackets to signify what the concentration of something. So when I put brackets around H plus like that, this symbol right here represents the concentration of hydrogen. So I should do this so that you can see those are the two ways that it can be represented. Now, when we're an acid, we've been talking a lot about acid ions versus base ions. And acid ions are H plus and base ions are OH minus. So what do you think? A lot of people, this is a misconception that a lot of people have, is that when you go from 1 to 7, all you have is H plus. And then once you go from 7 to 14, all you have are OH minuses. But that's not the case. The case is there's always going to be H plus and there's always going to be OH minus. The balance between the H plus and the OH minus determines the pH level. So what do I mean? Hopefully you're getting me so far. Strong acids are represented at the very low end of the numerical curve, and strong bases are represented at the top end. So the closer we get to this side, the more base we are. The further we get down this way, the more acid we are. Now, hopefully what you can deduce at the moment is that as we travel this way, oh geez, that was terrible. As we travel this way, the H plus concentration goes up. There's more H plus, makes it more of an acid. More of the acid ion makes it more of an acid. And adversely, the further I go this way, H plus up. OH minus goes up. But really what we could do is we could say that along this whole curve, H plus and OH minus is always there, and it's constantly either increasing or decreasing. And so even at 14, there's a little bit of H plus there. And as I get to 13, there's more H plus. 12, there's more, until I get to 1 where there's the most. And OH minus follows in the reverse way, that there's some OH minus, there is the base ion at 1, but there's going to be a heck lot more of it at 14. So when we look at a simple situation like this, all the way on the low end of the curve, when we're an acid, there's more H plus than OH minus. So the more H plus ions there are, the more acidic it's going to be. When we're on the opposite end, there's less H plus than OH minus. Again, because if there's more OH minus, it's a base, so it's going to have a higher pH. And when we're neutral, these two ions are equal. And that's what makes a solution neutral. H plus and OH minus are in perfect balance. Neither side of the graph, I can't think of a word for this, scale, each side of the scale is represented equally. And then as we divulge onto either side, those ratios kind of go in different ways. So as a definition, pH measures the acidity or the alkalinity. Alkalinity is just another word that means basicity, or how basic something is of a solution. So, we've gone through this enough, so I'm just going to leave it at that. And here's where the math comes in, but it's not going to be crazy, I promise. All right, it is defined as the minus log of H plus. So if I took a concentration of any solutions, H plus ions, and I put that concentration into a minus log equation, it would spit out a number 1 through 14, and it would give me the pH. But we don't have to do that. We don't have to do that. So, because here's how simple it actually is. Let's say this was the concentration. A solution has a hydrogen ion, H plus ion, of 10 to the minus 3. 1 times 10 to the minus 3. What's the pH? So what you could do is you could take this minus log 10 to the minus 3, or you could just say, well, if the exponent of this power of 10 is minus 3, and if I did plug that into the calculator, you're just going to spit out 3. So it's that simple at this level of chemistry, is just being able to take the concentration. Again, this could be written as 0.0, 1, 2, 3. Could be written as this. That would be in molar, big M. And if this was the concentration of a solution's H plus ions, 0.001 moles per liter, pH would be 3. So it's actually really simple. Just take the exponent, the negative exponent, and that becomes the pH. All right, let's take a look at a different one. So let's say the H3O plus concentration is 1 times 10 to the minus 11. H3O plus. We didn't talk about that. Yes, we did. We said that H3O plus equals H plus, so it's the same situation. If the H3O plus concentration is 10 to the minus 11, then the H plus concentration is 10 to the minus 11. And using the little trick that I just taught you, if that's the negative exponent, that's the exact scaled number of the pH. So it's 11. Very simple. Take the exponent, make it positive, that's the pH. So here's a reverse question now. What would the H plus concentration be if the solution was neutral? So we just have to work backwards. It's really not that hard. A neutral solution, assuming that you know a neutral solution has a pH of 7, what would the concentration be? Well, we were just talking that it's the minus log, so 1 times 10 to the minus 7. Because I know after we've done 2 examples, the majority of you would say, well, if this was the concentration, you take the negative exponent and make it the pH. Going backwards is just make it the negative exponent. Simple, simple, easy peasy. Now this is where we're going to just look at some new words and comparing and contrasting. So every time we change a pH unit, we call that a tenfold. So it's either tenfold increase or a tenfold decrease. 10 times increase, 10 times decrease. And that's because each power of 10 changes each time that we change a pH. So if we had an H plus concentration of 10 to the minus 2, the pH would be 2. Take the negative exponent, make the pH. If the H plus concentration was 10 to the minus 3, the pH would be 3. That's nothing new. But the idea is that going from 2 to 3 or 3 to 2 is a 10 times change. One way is increasing change, one way is decreasing change. But it's 10 times when I change one pH unit. The reason is because the difference between 10 to the minus 2 and 10 to the minus 3 is a 10 times change. It's either 10 times greater if I'm going from minus 3 to minus 2, or if it's 10 times less if I'm going from 2 to 3. All right. Now, I just want to take a second to just clarify this one little thing. Where is there more H plus? Is there more H plus at 2 or more H plus at 3? Be careful before you answer. Because if I have a stronger acid, I have a stronger acid because the H plus is higher. And if I have a lower, weaker pH, that's because the H plus is lower. And why I kind of bring that up to you is because if I go from 2 to 3, that is a 10 times decrease. And that's difficult for people to wrap their heads around because the pH number is going up. But just because the pH number is going up, what does that mean? You're becoming more basic. And if you're becoming more basic, you have less H plus. So it's becoming a weaker acid because the pH is increasing. And on the flip side, if I went from 3 to 2, it would be a 10 times increase. Why? Because I'm going from a weaker acid to a stronger acid. And when I have a stronger acid, I have more H plus. More H plus is an increase. All right, so a couple of quick things to finish this off. Sometimes you might be given a number of molarity, not a, I'm pointing at the screen, not a exponent. And then what you have to really do is you just have to convert your numerical concentration into an exponential concentration, and then just follow the same thing. 10 to the minus 4 is a pH of 4. So here's a little word game that we'll do, or problem, real life thing. A lake in the Adirondacks has a pH of 5 because of acid rain. The lake is treated with a base. It makes it 100 times less acidic. What is the new pH? So there's a trick here, by the way. If the pH is 5, what's the new pH? If it changed by 100 times. So here's the trick. And I know your math teacher is going to be upset because I'm just showing you tricks and not teaching you how to do it. But however many zeros there are is how many powers of 10 it's changed. So when 100 times change, it's changed 2 powers of 10. We've already talked about that 1 power of 10 changes the pH 1 unit. So if I change it 2 powers of 10, how many pH units does it change? 2 pH units. Moral of the story: zeros equal pH unit change. Going quickly because I think I'm running out of time. What is the new pH? So here's the tricky part. The new pH, if it started from 5, could be 7 or it could be 3. These are the two choices you have. That's a 2 pH increase and a 2 pH decrease. Again, you have to be careful because when it says less acidic, most people are just going to jump to, oh, it's less. So if it changed by 2 less, it's going to be 3. But the wording tells you that it says less acidic. And less acidity means an increase in pH number. That is going to be the trickiest part for you guys. it's going to be